Hello, this is Alex Sanguinetti. I would like to share with you a project as part of my machine learning course. I received data in regards to the combined cycle power plant. I was asked to take that data and create a model that would predict the energy output based on a set of input observations. There were 9,568 observations that included temperature, pressure, relative humidity, exhaust vacuum, and net hourly electrical energy output. After observing the data, which I will show you here, I decided that the best approach would be to consider this data as structured data. The data points are continuous, which would lend itself to using a model that would be based on supervised learning and linear regression, specifically multiple linear regression, as there were multiple features within the data set, as highlighted here. Beyond that, I decided that the target would be the output energy. So we had temperature, vacuum, humidity, as well as pressure numbers, with the target being the output. In terms of the tool to build the model, I decided to use Google Cloud's Vertex AI. There was a reference in the class to use their AutoML tool, but it is deprecated, and they've asked users to shift to Vertex AI, and that's what I have done. The data itself was split 80-10-10, so 80% of the data was used for training, 10% was used as a single validation set, and 10% was used for testing. Within this tool, the data was uploaded, and I'll give you a sense. So this is the dashboard on the tool. Went through data preparation as well as model development to get to the point where I could evaluate the model. This process was automated. If we go here to take a look at the data sets, you will see that I uploaded the data into Google Cloud, and from there connected via API the tools that were available to use a linear regression model using parametric algorithms, and run the modeling and repeat the running of the model automatically until it was ready to be used and viewed. When it was ready to be used and viewed, it was then put through a training process, and then you could evaluate the results of the model. So here is the data set. It's been ingested by the tool. The tool does a quick evaluation showing you the distinct data points as well as how many distinct values they are. You then went through a process to select the target or output values. Once that was selected, it then went through multiple tabular regressions until it found the best model possible. From here, I will show you that the tool allows you to look at multiple models in the model registry. I will select the model that was used. Across the top, you do have the evaluation metrics across the top. It automatically calculates these 5 metrics here, and it also provides you feature importance ranking. So as an example, you can see here that it was the temperature that had the highest correlation to the outputs, so that allows you to know the relative importance of each feature. And you can see up here that the results were very good. The output model is excellent. The R-squared, which was my chosen metric to determine or evaluate how good the model is extremely high. It's close to 1.0 at 0.954, so you know it's extremely accurate. The tool does allow you to understand at a basic level what these metrics mean. The other metric I decided that would be important is the MAPE, the mean absolute percentage error. as I find that this is the metric that's easiest to explain. In layman terms, it's at 0.62%. And as the definition of the tool will tell you, the closer you get to 0% means the higher quality of the model. The MAE numbers, the mean absolute error, as well as the root mean squared numbers are relatively low, but these two metrics I found were the easiest to explain. I hope you enjoy the presentation. Thank you very much.